Graph-driven planning pitfalls. Terraform constructs a dependency graph before it proposes any infrastructure changes. The graph is built by parsing references between resources, variables, and data sources. Each reference becomes an edge that defines execution order. Terraform then walks the graph to decide which resource must be created, updated, or destroyed. The outcome is deterministic planning because operations follow graph dependencies rather than file order. Terraform automatically infers dependencies when a resource attribute references another resource. The expression awsvpc.core.id creates a graph edge from the security group to the VPC. Terraform delays the security group creation until the VPC exists. The outcome is correct ordering without explicit instructions from the engineer. A graph edge only exists when Terraform can detect a reference. Hard-coded identifiers bypass the graph because Terraform cannot see the relationship. The planner then treats the resource as independent. The outcome is a race condition where Terraform may create a resource before its required dependency exists. The depends on meta argument manually inserts a graph edge when Terraform cannot infer one. Terraform adds this edge to the dependency graph during planning. The planner then guarantees execution order even if no attribute reference exists. The outcome is deterministic deployment when infrastructure relationships are operational rather than structural. Beginners often assume Terraform processes resources sequentially from top to bottom. Terraform ignores file order because the planner executes nodes based on graph topology. Two resources without dependency edges can run in parallel. The outcome is faster deployments, but also surprising failures when hidden dependencies exist. On a submarine, equipment startup follows a strict dependency chain. A cooling pump must run before the reactor loop is activated. If a technician skips the sequence, the reactor protection system trips. Terraform behaves the same way. The dependency graph is a startup checklist for infrastructure. Missing a dependency edge is equivalent to starting the reactor before coolant is flowing. The outcome is deployment failure that appears random but is actually deterministic.